Good day everyone. This time we focus on kiln operation, applying first feed till reaching full capacity. In this video I will explain step by step one of the methods typically used to feed a clinker kiln. You will be able to follow the system behavior as seen on the control panel. I will be using my specific kiln system and share with you what I do and see on the control panel. Please read this disclaimer very carefully. What it says, in short, is that your kiln may not react as mine, and I am not responsible for any incident or failure on your system because of your trying out the procedures described in this video. To start with, I show my system running at full capacity. It is a 5 stages preheater with air-separated precalciner, 200 tons per hour feed, or 3000 tons per day clinker production. Take note of the temperature profiles on the preheater tower, the specific thermal energy consumption. Notice that we're firing coal, 60% of it on the precalciner. We have some remaining capacity in the induced draft fan. The kiln runs at 3.5 RPMs. Tertiary duct is set at 3/4 of its position, and we can see there are 2 grates on the clinker cooler. Here as well, take note of the temperatures and pressures of the system. Notice in particular a good burning zone temperature, nice secondary temperature, and a very cool clinker temperature exiting the cooler. Looking at the cooler, we see 8 undergrade fans, 2 grates, and the usual control loop between waste air and kiln hood. Here we are with the kiln system preheated after 18 hours of preheating program. Before proceeding, let's review a bit of theory. The basic kiln controls are linked with a cross relating the draft, the fuel, the feed, and the kiln speed. When starting, we create some draft, start the fuel and fire it. Then we continue with more draft and more fuel, going on and on like that, following the preheating program, always making sure the kiln is turned accordingly. This is the point where preheating is finished. By then the kiln is running on auxiliary drive. This is precisely the situation we have now on my system. How do I know that my system is ready to feed? I look at the preheater side and see it is very hot. Even with some tertiary air open to bring cold air from the cooler, I get almost 380 degrees Celsius on the ID fan. My system does not have a bleed air to keep my fan and filter cool, unfortunately. So I'm back to the theory, ready to feed. I will add more draft, fuel, feed, and increase the kiln speed. But how much first feed should I apply? To make it easy, we could add very little feed. But this brings 2 issues. It will take too long to reach full capacity, and the preheater tower will not function efficiently. What do I mean about an efficient preheater? Because of the dimensioning of cyclones and ducts, the preheater needs a large volume of gases to lift the material and make it flow as shown. With very little feed, I will not have enough gases and the material will just drop down the preheater into the kiln without being decarbonated. The other extreme is to go directly at full capacity. This is very dangerous to expose my system to such a sudden increase in thermal load. Finally, What is considered an adequate first feed? The rule of thumb says it should be at least 30% of the nominal capacity. We start the fan, fuel, feed, speed, and keep on running this cycle till reaching full capacity. If you notice, there's a ratio between these parameters, even with the kiln speed. Do you know what these ratios are? Think about them for a moment. The first one is simply the O2 content, then the specific thermal consumption, the kiln filling degree, and the settings on our clinker cooler. Changing the slope of these ratios will affect the behavior of the system as shown. Now that we have revised the theory, let's go into practice mode. As seen earlier, full feed is 200 tons per hour, 30%, 60 tons per hour. At the moment we have enough oxygen. In addition to the ID fan, we also have a natural draft created by the 5 stages preheater. We are ready to add the 60 tons per hour. Keeping an eye on the O2, it will drop drastically once the feed is in the system. And it does drop at kiln inlet. We also generate CO, increase more draft. We see the gas temperatures on top of the preheater coming down, and the O2 going down as well. Let's add more fan. Notice how the temperatures start decreasing on the second stage. The CO at kiln inlet is showing now at preheater exit, though diluted by the fresh air from the tertiary air duct. No need to react. Material reaches the third stage. And the fourth stage. It is time to start the precalciner fuel. Notice the specific thermal energy consumption going up. I'm heating up the system. Do not have the exothermic reaction generated by the halide formation. I will need much more energy than required in normal stable operation. I am also increasing the burning zone fuel. We need to prepare it for when the material reaches it. Material is now at stage 5. Obviously the preheater ducts are very large and I still do not have enough gas flow. It looks like some of the material discharged by stage 3 fell through directly into stage 5. Let's have a look at the precalciner temperature. You can see the peaks of increase when I started the fuel. A bit more fuel on the main burner, once again to prepare the burning zone. By the way, I will fire natural gas during the complete procedure, even though we have seen the full capacity condition firing coal. We will do a fuel exchange in another video. Time to increase the kiln RPMs. The material is entering it now. You can see the precalciner temperature going down. Giving more air to the precalciner and to the system overall. The decarbonation of the raw mill has started, and the CO2 generated is displacing the overall air pulled into the system, explaining why the O2 is going down. A peak of CO, preheater exit, and since the O2 at kiln inlet is high, I just opened the tertiary damper. My temperatures of precalciner and stage 5 are increasing. Stage 4, 3, 2, 1, and ID fan. Still having CO, opening the tertiary damper a little bit more. CO still climbing, more air. Okay, going down. You notice that the secondary and tertiaries are very low. Clearly, the clinker cooler is empty and we're pulling ambient air into the system. You also see a cool burning zone. This is normal because the parameter is pointing below the flame and there's no material there at the moment. More fuel at main burner. Nice gas temperature at stage 5. You can see the effect of firing the precalciner. It is important to start the precalciner rapidly after feeding. Remember, it will take only about 3 minutes for the material to reach the bottom of the preheater and get well precalcined, while it will take around 40 minutes for the material to reach the burning zone. This is why we have some additional time to heat up the BZ before the material gets there. High thermal consumption compared to the nominal value, but we need it to get our first clinker. You see as well we have a 28% of fuel in the precalciner, while at full capacity we should run at 60%. Let's have a quick look at the clinker cooler. On the hot side of the cooler, I started the grades 1 and 2 at low speed and the first 4 fans. This is to protect the system even though it is running empty now, and to make sure it is already running when the first clinker arrives. The circle shows a middle layer extraction, used to add more heat to the raw meal. We will not deal with the raw meal now. On the cold side of the cooler, the fans are stopped, and the waste air fan is running in automatic mode. See the A for auto. The fan controls the hood pressure. There are also manual modes, M, in the system. In this case, the undergrade fan controls the damper position. A word about controlling my oxygens. The O2 at kiln inlet is controlled by the ID fan. The O2 at preheater exit is controlled by the tertiary duct. But of course, the tertiary duct will also affect the kiln inlet, and the ID fan will also affect the preheater exit. In short, you have to look at the reaction of both O2s when you make changes in draft. After 30 minutes of feeding, notice the operation time will be displayed on the system. Still no material detected in the burning zone, BZ. O2 levels are nice and low, no CO. Burning zone temperature increasing slowly, kiln drive power increasing, kiln inlet NOx increasing, stage 5 temperature very nice and stable. Temperature at ID fan hot but stable. Minute 43, BZ temperature shows a sudden increase, material is there. One hour, BZ temperature increasing steadily. Kiln NOx as well. Temperature at ID fan is way too hot. Notice that at minute 50 I already increased 4 tons of feed. It helped to cool down the gases, but now I must act again. One hour 15, 70 tons per hour feed, and the preheater still very hot. 1 hour 30, 76 tons per hour, preheater still hot. Two hours, 100 tons per hour, preheater very good. Notice that I have increased the fuel ratios, basically providing fuel where it is needed. Two hours 15, looking at the graphs starting from the beginning, that is, when the material was first fed into the preheater. The black line, the BZT, is starting to go down slightly. The red line, back-end temperature, stabilizing at around 1000 degrees Celsius. O2 kiln inlet a bit too high at 4%. The rule is keep your O2 as low as possible, making sure you do not generate CO, not even traces of CO. Let's clear up these graphs. The green line, pre-calciner fuel, and in brown, the main burner fuel. Notice that they're converging towards each other. Ultimately, we will reach the 60% pre-calciner to main fuel ratio. The clinker cooler, I have started the last 4 fans and set them all to auto mode. I see that fan 1 cannot deliver the flow. It means that there's too much material on top of the grades. I will need to speed them up. 3 hours, 120 tons per hour, 2.6 RPMs kiln speed, 51.9 precalciner fuel. Let us speed up the system to quickly see what will happen next. Increasing all the settings, evidently too fast, reducing CO2 drastically and generating CO. Four hours, going to 156 tons per hour. Kiln is running at 3 RPM. Precalciner fuel is still at 51.6%. The cooler is stable, though I see that the clinker temperature is increasing, and I still have the fan number 1 not able to deliver its flow, even at 100% damper. Too much material in that zone, I need to increase the grade speed. On the graphs, the BZT in black is stable, but a bit too low. O2 in red was better at around 3 to 4 hours of operation, but now I keep it slightly too high. At 5 hours, the graph shows a nice progression of my precalciner fuel in green, overtaking the main fuel in brown. Five hours 30, getting ready to add the last 4 tons. Preparing the system with additional draft. A bit more fuel. The feed. And the speed. I see that my clinker temperature is extremely high. Time to work on the cooler and improve the overall system to achieve a better heat consumption and assure clinker quality. Thank you for your interest. In case you would like additional information or need to deal with other subjects on kiln operation, please leave me a message or email me. All details are provided in the description below. Cheers, until next time.